Something is wrong with this server. 5 requests came in and the memory went up. But the work is finished and it is not coming down. 113 megabytes will never be used again. This is a memory leak. By the end, you will watch it kill a server. In the next 4 minutes, you will learn how your machine thinks. That stays with you for years. Start with a simpler question. Who cleans up memory at all? This big array has one arrow pointing to it. If the arrow dies, does the memory leave? It does, and no line of my code did that. Java has no delete. Something else cleans up behind you. It is called the garbage collector. To see why, you need the collector's one law. A few things in a program are always alive. The variables your code is using right now stays alive. Anything marked static stays alive. These are called the roots. The collector starts there and follows every arrow. Whatever it reaches, it keeps. It never asks if you will use it again. It only asks if it can be reached. Now, a static list also points at the same array. My arrow dies and nothing leaves. It is reachable, so it stays alive. Hold the thought. When the collector runs, it first stops your whole program. This is called a stop the world pause. Next, it walks from the roots and follows every arrow. Everything it touches is marked alive. Then, few survivors get carried out to a clean area. And the old area is wiped clean all at once. The dead are never visited. My machine's log shows it. It cleared 150 megabytes of garbage in half a millisecond. Here's a strange question. 6 million objects are alive and 6 million are dead. Which side is slower to clean? The living side took 29 milliseconds. The dead side took 3 because the dead are never even looked at. The cost is what survives, not what dies. Remember the stuck memory? 113 megabytes are still sitting there. The server saves every request in a static map and nothing ever removes them. That map is pinned to a root, so the collector must keep every byte. A memory leak is not memory the collector missed. It is an object you can still reach but will never use. The fix is one line. Remove it when the work is done or give the cache a limit. A cache with no limit is a leak with good intentions. A cache is not the only trap. Timers and listeners hold the object the same way. The last trap is hidden inside the language itself. I keep 3 tiny summaries here, just a few numbers each. How much do they weigh? They weigh 69 megabytes. Each summary was born inside a 20 megabyte report, and an inner class secretly keeps an arrow to its parent. Here it is in the compiled code, a field you never wrote. You kept 3 tiny notes, and 3 huge reports came stapled behind them. JavaScript does the same thing with closures. The fix is one word. Make the class static and copy the number out. Now I keep my promise. Watch a leak kill a server. I made the heap small on purpose. 256 megabytes and let the leak run. The collector works harder and harder and gets nothing back because everything is still reachable. Watch the counter. At request 42, it ran out of memory and the program died. Last episode, the stack killed the program. Today, the heap did. On a real server, this takes days, not seconds. Keep one rule. A leak is an arrow you forgot to cut. So cut it or give it a limit. Now you know where your data lives and who cleans it. One question is still left: how big a memory can get? Next time, an AI model wants 4 gigabytes and the server says no. Subscribe and understand the systems you build on.